Alrighty, let's get started. The future is graph, strategic edge of GQL. So, yeah, so why this talk? I was a bit no, I should actually start here. Um, what do I have to? Oh yeah, okay. So I guess a lot of people in the room know me, but maybe not everybody. My name is Stefan Plantikow. I'm principal engineer at Microsoft Fabric Graph. I'm also principal editor and initial author of the GQL standard. And a long-term contributor to Property Graph, SQL PGQ, as well as OpenCipher before all that, right? And I think my main focus really is, especially here in the context of the Graph Data Council, is GQL design and evolution. Of course, I'm trying to push that ahead. Yeah. So when I was invited to this talk, a lot of people will know that I used to be at Neo4j. So now it's one of my first public talks with a Microsoft affiliation. So everybody is, of course, keen to learn about Microsoft Fabric Graph. I cannot yet speak about Microsoft Fabric Graph. It's as simple as that. As those things sometimes go. So then I have also the fun of having usually a lot of overlap in common with Keith, since we both work on GQL. So I was a bit challenged of what I should be presenting here. And so what I realized would be good to do is to kind of try to take a bit of stock with where we got with the first version of GQL. What's unique about it? What's maybe not so obvious that it's unique about it? And kind of try to take a big picture look, especially with LLMs and all that's happening, and then focus on one or two particular things we're doing in the standard to kind of move in the right direction. Okay, so that's kind of what I'm trying to do. And so, yeah, I already said that, so no need to repeat it. So where's GQL today? We have an international standard for property graphs since April 24. We just heard from Ricky about a fantastic book that has been written on it. We also already today saw something like this list. I'm really happy about the uptake in implementations we're seeing. It's really amazing, right? We have Google Spanner, TU Graph, Ultipar, Pyro, I learned yesterday. Falcor, I'm kind of watching that a little bit myself. Puppy Graph, Nebula. So there's a lot of really new implementations coming, but we also still have, of course, all the OpenCipher vendors who are kind of very close to GQL, right? When they're not already fully compliant. Yeah, of course, Neo4j being the big one and AWS. And I'm sure more are going to come. So what are the foundational achievements of the GQL standard? So the first one is that we now have a universally agreed definition of what a labeled property graph model is, right? That's big. We didn't have that, right? We have graph types. We have a schema model, not yet complete, more work to be done, but we do have a schema model now, right? We didn't have that, right? We have a very powerful graph pattern matching language, and that really got more powerful than what Cypher had over the course of the standardization process. I really have to also here give credit to Oracle's contributions to it as part of SQL PGQ, right? But not only, other people got involved, and it's still evolving. For example, the committee currently is working on adding cheapest pass to it, right? Which is a very common ask, right? Yeah, this is kind of interesting for language geeks, right? We have a standard execution model. Boring, I know, but somebody has to define it, right? So we have sessions, transactions, we have standard error codes, if you haven't seen that yet, on which users can rely, right? And I mean, the vendors get it right, asterisk, but still, right? We have a modernized type system with support for both static and dynamic typing. If you want to hear me cry a river about what that really meant, making that happen, buy me a beer later. Um,
Or two.
or two, yeah. Uh, and we are SQL compatible, which is also a major feature because it allows the universe of data out there to be graphicized, if that's a verb now. Okay, so what's the strategic edge of GQL, right? So here we have a little query. This is my standard introduce GQL query. We have the kind of boring stuff around, like we can set session parameters, we have transactions, and then, okay, we have a simple query, right? We are multi-graph, right? Use social graph. We do pattern matching. Then we can do fun stuff you like to do in relational algebra, like apply a filter. We have DML. SQL PGQ does not have DML. We can do updates in GQL, right? And of course, that we can do the usual stuff like returning an aggregate. So what's unique about the language? Stepping a bit back from these more foundational things, right? We have a composable query language that can build tables from graphs via pattern matching and tables from tables via statement, what we call statement composition in natural reading order, right? Cypher's unique idea, I think. We have fairly complex control flow. What's also maybe not immediately obvious that contrary to SQL, at least before you get into things like SQL PL, we can allow arbitrary combination of reading and writing in a single query. I hope that's the correct statement. Keith is nodding, that's good. Because he knows SQL way better than I do. Combining data sources, right? I already mentioned we can work with multiple graphs of different or the same graph type, right? So think ontology. And we have, that should have been on the foundational slide in hindsight, right? We have coherent modern foundations, right? So if you read the SQL thread, you find a lot of IT history there, right? We left some of that behind, and good riddance, right? So I know everybody takes these things for granted, right? But somebody has to do that, right? Move to Unicode, move to ISO 8601 for temporal in a way that's backwards compatible with SQL. Keys, I think, might have lost a hair or two over making that happen, right? IEEE 754 floats are recognized and allowed by GQL, something everybody takes for granted in programming that is not yet the reality in SQL, right? Vendors do it, not in the standard. Yeah. Power of two integer types, not in SQL, right? And as you move closer to analytics and graph processing, well, you want those, right? Because that's what's fast. That's what's vectorized in your CPU, right? Nevertheless, maintaining SQL compatibility. So are we done? Said Panda, no, right? So composable query language, right? This is just some, there's a much longer list of those, right? What about dynamically projecting and annotating graphs from tables? What about returning graphs? Keeps coming up, right? For visualization, for example. Complex control flow. What about supporting more complex logic? Combining data sources. What about composing graphs from graphs? What about treating the system state as a graph, right? All these fun things that we haven't yet done in version 1. Also on the foundation level, there's, room for extension. JSON is kind of important, right? There's a bunch of other data types we're missing that would be good to add. Data model extensions, N-ary edges, or at least edges pointing at edges. Anyone, right? And then there's also the whole question of common protocols and APIs. I think that's a discussion that's really missing in the industry currently. Like, how do we get a common interface, JDBC, protocol, whatever, to GQL, right? A lot of people like to piggyback on Neo4j bolt drivers. I can understand why they do that, but I think that's not really a tenable solution for the field as a whole. So something needs to happen there. So we have a mountain of work ahead of us. How do we climb it? How do we scale it? And where to start? Well, enter AI, right? AI is great in a way. In a way, it's also horrible, right? Imagine spending 6 years of your life on a new graph database language, and then somebody invents large language models, and everybody talks about that, right? So that's me about a year ago. The good thing is it's a forcing factor. That's what AI is, right? It forces us to kind of relate to it. And by doing so, it sets priorities, right? And that's good. That's useful. Because all the things we could do, the adage about product management is not about what you do, but what about what you don't, right? So it forces that, right? So I try to make a list of 5 things we could be doing that would relate GQL with AI, right? GQL for data integration, for consumption by AI. Data integration is getting more and more important, right? In order to feed AI models, right? And various other, and that points towards supporting complex workflows, that points towards supporting multiple graphs and views, obviously, if you want to do those kinds of things, right? GQL for GraphRag, I'm not going to speak about that because Keith is going to tell you a little bit about what we're doing in that arena. NL to GQL, I'm also not going to talk about that because we had a fantastic talk about that earlier, right? With the TGGQ initiative here launched today. GQL for agentic memory, right? You've all seen the MCP servers that try to provide, enhance AIs with essentially property graph state, right? So I'm sure there's a lot to be done there. I would again say multiple graphs and views for the simple reason that, if you done a bit of experimentation with AI-based programming. You know, you really want to control the context you provide, right? And what better device to do that than a view? Common interfaces also comes up again here, of course, right? And then AI in the database, I think, is an umbrella topic that I had kind of expected to have seen more on that by now, like running AI models in the database, training models directly in the database. I haven't seen that much on it, but then I'm also not an AI guy. So, but I'm kind of hoping that a bit more will come there. Okay, so now I said this is kind of more the high level picture. Let's make things a bit more concrete. GQL evolution, what are we doing? So you see here in the, how do you call it in English? I guess the more bluish tint. The things I want to focus on is what are we doing to do better support for complex workflows, and what are steps we can take that move us a bit closer towards make it easy to work with multiple graphs. Views not so much yet, but points at that too. So next, GQL next will have conditional statements, right? And what is that? That's basically a statement that allows you to switch or by a predicate on each incoming row and run a different subquery depending on which predicate triggers. The same that case works at an expression level, just do it at the statement level, right? And the way we've done it, or at least in the current design, of course the standard isn't out, it could still change, right? Is really, it's kind of tied really in high level. Like it's not even a separate statement. It's like the basic GQL query will be conditional by default, unless you don't do that, right? So you see that here, I have a simple example with the match return next. That is basic GQL. If you have never seen return star next, it's like this star in Cypher, right? And then it pipes directly into a conditional statement and does some tests. When A city is B city, then we do one query, otherwise we do the other query, right? And there's many extensions planned for that. This is just the baseline. The baseline is Indo, support for discarding branches, usual break in a conditional. There's an idea of doing something. SQL has this fantastic thing in case where you provide a value and then you don't have to write the same expression on each conditional again. Simplified case. We could do the same thing here. There's also an idea of having what I like to call match and run conditionals, where kind of you test like with an existential predicate, but you keep the matches. Like, run an existential query. If you don't find anything, it's a false. If it's a true, it's a true, but you keep the matches, right? So that will also be pretty nice if you do it. Yeah, there's more here. Grouping calls. So some people might have, we had a talk about that in the break earlier, in the coffee break, right? So one thing GQL did over Cypher is that it broke up this, right? In Cypher you have this with, all these different, with all these things you can do, filtering, sorting, aggregation, all in one statement, right? A bit like select in that sense. And in GQL, based on discussions with Leonard Lipkett actually originally, we decided to break all that up, right? So in GQL, you have let for binding, filter for filtering, and those things. We didn't do that for aggregation yet. Aggregation still uses group by, which is also a slight difference from Cypher, which kind of infers the grouping key. So GQL has explicit grouping keys. And so one thing we are considering currently is a form of, and the semantics are still a bit under discussion. So is this really like more like a peek at what might come? Is a form of a partitioned nested procedure call. So where you take your incoming binding table, you partition by the provided key, and then you run a subquery on each partition, right? And then, of course, in that subquery, you could also do aggregation. And what that gets you essentially is grouping, I think, done in a better way, because you first state the grouping key and then you get into the actual, aggregating query. So that's more on the side of enabling more complex workflows. But what I want to focus on for the last part now, how much do I have actually?
2 minutes.
Let's see. Is working with multiple graphs made easy? GQL already allows working with multiple graphs, but the big thing we haven't solved is how to identify nodes across graphs. You can always match them if you know your schema, but it's a bit heavyweight to have to do that. The standard in principle allows sharing of nodes and edges between graphs, but there is no syntax for expressing that. It's something a vendor might be able to do. But what if the graphs have been created completely separately? Well, how do we do identity, primary keys, right? That's how we do identity, right? And of course, lack of constraints is one of the most frequently missed features from GQL 2024. And anyhow, we already had the amazing PGQ paper, so let's get into that, right? So I heard you want to define primary keys. Um, Defined where? Well, that's the first question, right? The picture is a bit more complicated. SQL usually only needs to define them on tables. We have to define them on graph instances, but also on all instances of a graph type. So the setting is going to be a bit different. Targeting what? Nodes and edges, right? Using keys constructed from properties, but also from the endpoints of edges and their properties. Yeah, it should say endpoint properties there on the third bullet. And yeah, I need to move a bit quicker now, I think. So to give an example of what the current proposal looks like that Alistair mentioned earlier, that's now also posted as Lex 96 here in the LDBC, that's coming from Microsoft. Take your simple person-employee graph, right? And maybe we have cars also. You can define primary keys under this proposal by giving them a name. Then you state a pattern that selects the nodes. And this is a covariant pattern, like a match pattern. So it might select nodes from multiple node types. Yeah, and then you just state your key. And more interesting perhaps for edges, right? You can do fun things with this proposal because you can, for example, for an edge here, I have person assigned to car, right? And then I say the endpoints must be unique. So the endpoints becomes a primary key. Yeah, what that does is it stops the graph being a multi-graph. It's now just a plain directed graph where there can be at most one edge between a pair of nodes, right? You can do a singleton. Anybody remember Neo4j's reference node here? Hands up. No? Okay. Neo4j used to have a weird feature. In the Java API, you were able to say get reference node. It would create exactly one node if it didn't exist. And if it existed, you got it back. That was before the introduction of labels and indexes. And from there, you would explore your graph. So that brings back singletons if you want that. Um, yeah, so it will not only be on graph types, it will also be possible to do it on graphs. So I'm not going to stop there too long. Last thing, the great thing about primary key, and thanks Keys for reminding me of that the other day, is it will unlock merge. So Cypher has a complex feature for upserts called merge that probably a lot of people know, maybe. And the problem with merges and why it's not in the standard is the semantics are complex. In the general case, they are not even deterministic. So it depends on the order of the rows in the incoming binding table, what result you get. And that's why we didn't pull it into the standard, because that's messy, right? Luckily, though, if you restrict merge for nodes and edges, which are identified by primary key, it becomes deterministic, right? So the nice thing is once you have primary keys, it is more realistic to come up with a portable definition of merge that doesn't suffer from these non-determinism issues. And then of course vendors can always go beyond that. So that's another little side effect of that. So yeah, here just finally, the other thing that the paper does, and that I hope that will be more interesting for the actual discussions in LAX, right? It also introduces a framework for constraints in GQL, right? Just very briefly here, a constraint applies to one or more graphs, which we call subjects now. For each subject, it selects constrained elements, so the nodes and edges affected by the constraint. And then it forces some constraint requirement, right? And I already showed you here primary key constraint. The proposal from us also deals with unique constraints, but there's a lot of stuff missing. Cardinality constraints, I think, are really important. Domain constraints, complex check constraints, right? And so forth. So what's next? I'm trying to wrap it up a bit here. GQL is evolving, I hope, or I think it's a good aspirational aim for all of us to be the ideal partner graph query language for AI, right? And a lot of work has happened, but also a lot remains, right? I mentioned a couple times already today in discussions, the working draft lists many language opportunities. Have a look, right? If you really want to get into standards, there's everything. It's like people tell you to join open source projects. Look at the issues list, get useful. There's also small things there, right? It doesn't have to be a 60-page paper that only 4 people really can appreciate. So I think now is the perfect time to, mirroring, I hope a bit what Ricky was saying, now is the perfect time to push GQL to the next level here in the LDBC or in the JDC as of today, or of course via ISO directly in WS3. So that's what I wanted to bring.